So here we go. And I'm going to do this in red so it doesn't bleed through. So for our start here, we're going to talk about some, again, we're doing some vocabulary. We talked about already in the warm-up. We'll do it one more time here. So the mean, okay. How do you find the mean again?
Add them all together.
Yes. So it's the sum of the data divided, I have no idea, divided by the number of data points. I'll close the door here. Do you guys know what that was?
No, it's just really annoying about time.
It's like a trumpet holding C notes all like two of them.
Close the door. Okay, so sum of the data divided by the number of data points. Okay, so add up all the data, divide by the number of data points. All right, median. What's that again? How do we find it? The middle number after you put them in order from least to greatest, okay? So the median is the middle number after you put them in order from least to greatest. Or greatest to least. It can be either way. Okay? Now, what happens if, when you're trying to find the median, what happens if you're trying to find the median and you're like counting in and you get to two numbers and there's no number between those two numbers? What are you supposed to do? Let's go to Hannah.
Don't you add them together and divide by 2?
Add them together and divide by 2. Okay? So if you have an even number of numbers, okay? If you have an even number of numbers, even number of data points, you're going to count in, and you're going to get two numbers, and there's not going to be a number between them. So you have to add them together, as Hannah said, and divide by 2. Okay? That's how you would find the median if you have an even number of numbers. In our warm-up today, we had an odd number of numbers. Remember, there was 9, and so we could find that middle number without having to do that. Okay. The mode. What is that again? It's the number that... Yep. Most often. Yep, or most occurring. What happens if no number repeats? Is every data point part of the mode then? No. Okay, it's not. All right, so if you have no number that repeats, you would say that there is no mode. Okay? What if 2 different numbers repeat the same amount of times? Okay, so can we have a mode? Can we have a mode that's got 2 numbers in it? Cameron, do you want to say it?
You just put them both next to the answer.
So we could. There are situations where we could talk about bimodal data. Bi meaning 2, modal meaning mode, right? So there are situations where you could have 2 modes. Okay, but as soon as you start going up to like 3 modes or 4 modes or 5 modes, eventually you want to say there's no mode, okay? Because here's the issue, right? Mean, median, and mode are supposed to measure the what of the data? The middle, or the center, okay? How many centers should something have? 1, right? If you start saying the mode is more than 1 number, you're saying your data has more than 1 center. Sometimes that is useful, but oftentimes we just want to say, no, we need 1 number, and if the mode happens, if there's several different modes, and we say really no mode. It's not really helpful, right? So just keep that in mind. And again, these collectively, all 3 of those together, are central tendency. Okay, central for center, tendency for like the behavior, okay? What is the tendency for the center of the data? Where is it located? Okay, the range is not a measure of central tendency, nor is the interquartile range, and that kind of stuff, okay? How do we find the range again? What do we do? Yes, so it's the difference of the greatest and and smallest data points. Okay, and I say difference, but that really means subtraction, right? Okay, the difference of the greatest and smallest data points, subtraction.
So you subtract the smallest from the biggest.
Yeah, smallest from the biggest. You take the biggest minus smallest. IQR, short for interquartile range. This data, this information often comes up when we do the blank and blank plot. Box and whisker plots. Yes, the box and whisker plot. Okay.
That's Q1 and Q3 and quartile 1 and quartile 3.
Yep. Very good. You remember, Trey? Yes, sir. Okay. The inner or inter, it's kind of used, both words are used. The inter or interquartile range, that is the width of the box and whisker plot. Okay. So the inter or interquartile range is going to be Q3 minus Q1. I'm just going to write it like that. It's easy to do. Okay. Okay. Q3 minus Q1, where Q3, well, we're going to talk about those right here. Q1 is known as the lower quartile. And Q3 then would be known as the, well, we're going to call it upper quartile. Upper. Okay. Quartile, that prefix quart means how many? 4, okay? So the quartiles split our data up into 4 sections, 4 quarters, or what percent would that be? 25%, exactly right, okay? So each quartile splits our data into 25% chunks, okay, of data. Okay. Yep.
Like on a box, it's like 1, 2, 3, 4, right?
Yeah, so quartile 1 is the first part, so like you have the whisker. That whole whisker is the first quartile, and then it comes up to the edge of the box, right? And that's where Q1 is. And then from Q1, there's the middle of the box, which, by the way, we have Q1 and Q3. We don't have a Q2 listed. What is Q2? What is the middle of the box in a box whisker plot? It's the median, So median is Q2. I'm going to put that up here. Okay, that's quartile 2.
Then it means Q1.
Sorry, again?
Is mean Q1?
So mean, nope, mean is not even, doesn't show up on our box and whisker plot, actually. The quartile 1 and quartile 3, like, so quartile 1, it's like the, let me do it this way. When you find the median tray, right, it's in the middle of our data. So in other words, the median, we have half of our data less than the median, half of our data above the median, right, because the median's in the middle. So to find the quartile 1, you take the median of the lower half of the data. So you take your lower half of data and find the median of that. That's quartile 1, okay? And then for the quartile 3, you take the median of the upper half of your data. That's quartile 3. Okay, we're going to do that here in a little bit here too. If not today, then tomorrow for sure. Okay, what about outliers? What are those? You had it, Chloe. It was up there. I could see it, and then it was gone, right? Let's go to Alex. What do you say?
Number that doesn't fit into the set.
Yeah, what do you mean by doesn't fit?
Like it's either like way too big compared to other numbers or
Yes. Okay, so outliers, data points that are extremely high or low when compared to others. Okay, data points that are extremely high or low when compared to others. Okay, there's actually a calculation to determine whether something is an outlier or not. Okay, we're not going to worry about that calculation because I feel like that's beyond what we need to worry about for our class. Okay, I think you guys will be able to determine whether something is an outlier or not. All right, if we go back to our warm-up. Okay, sorry, I know some people are still writing. I'll let you see it in a second here. What would be, give me an outlier that would be too high for this data set. So, Hannah. You don't have to pick a data. You can make up your own data points.
Like 9 or 10.
9, yeah, okay. The highest data point we have here is 4.7. Everything else is kind of like between 1 and 4. So 9 is like almost double the highest data point, right? So it's like, probably not. What would be an example of another outlier? Maybe a too low outlier. So, Olivia? -1, possibly. Or you could go even create like -100. Right? For sure, -100 would not fit in this data. That would be an outlier for sure. So, things to keep in mind there, okay? Outliers, I'm thinking are going to be obvious for us to see. Okay? So, remember, we already went through this, right? Your calculator will also tell you this information. Enter the information into L1, do stat. Wow, that's not how you spell calculator. That's not how you spell calculator. Now I'm mad. Anyway, press stat, then edit, and then stat calc, 1 bar stats, and then hit enter, and that'll give you your information. So you remember X bar, there's your mean. N is how many numbers you put in. Min X is your minimum, your lowest value. Q1, you know what that is. Median is Q2, or your median. Q3 is your upper quartile. And then max X, that's your highest value there. Okay? So, let's go ahead and find mean, median, mode here for 1 and 2. So you guys go ahead, take like a minute or two for 1 and 2. Find the mean, the median, and the mode there for your sets of data. For 1, find the mean, median, mode. For 2, find the mean, median, mode. Okay? So go ahead and do that. You can use your calculators if you want to, or you can just do it. Okay? Just go ahead and take a minute and do it there. Try 1 and 2, please. Okay. There's your answers for 1 and 2. So number 1, your x bar or your mean, 20.875. Okay, and yeah, I just gave the full answer there. It didn't say how to round, so I didn't bother rounding, okay, because I could just write out 3 decimal places there. Median was 22, mode is 23. Okay?
Wait, on the first one, did you mean 23, not 22?
For the median,
Yeah.
I think it is 22. How'd you get, you got 23 there, Braden?
I think mine is.
Did you write them in order?
Yeah.
Okay, so let's do that. I'll show you that here real quick here. So let me just do that. I'll put it over here on the side. Okay, so let's see here. The lowest number is 16,
16,
then 17,
18,
then 18,
24, no, 23.
21, and then 2 23s, and then 24 and a 25. Okay. Did you count in from there, Braden? Did you kind of count in? Like that?
Yeah.
So 16 and 25. Then we'll go in 1 each. 17, 24. Then 18, 23. Then 21, 23. You see, and so we get to it in the middle, and there's 2 numbers in the middle. So you have to add them up and divide by 2. 21 plus 23 is 44. Divide by 2 gives you 22. So 22 is the answer. So right there. Okay. All right. And then there's our mean, median, and mode there for number 2. Mode. Number 2, none. There isn't one. None of them repeat. The median is 200, and the mean there is 213.8. Okay. Any outliers? Any outliers you see here? Number 2, what do you say, Kim?
26.
Yeah, 326 seems kind of large to me. Okay, because the next highest number is 211. All right, so it's like over 100 more. You know, but I don't know. Again, it's kind of up for interpretation there, but 326 seems a little high to me. Seems a little high. Okay, questions on any of that? All right. So of course, part of statistics, right, is the analysis, right, looking at things, determining the center, determining how spread out things are and all that stuff. We'll come back to like the box and whisker plot stuff here in a second, but I want to talk about some other ways to display data, okay? Because obviously when you look at just a list of numbers here, right, looking at a list of numbers, it's hard for us to like understand all the numbers at once, right? Sometimes just it's overwhelming, okay? And so instead, it's helpful to draw a picture that represents these things. And so there are some different types of graphs that we want to be familiar with, okay? So first we're going to talk about is a dot plot. Okay, you can see what it looks like right here. It's kind of hard to see. It looks like we're talking about passengers, and then you can see how many passengers. Okay, each dot represents one person. Okay. So, why is a dot plot used? Well, it is used to display, I'm trying to think, how do I want to say this? Use display let's say this. Use to display how often a single data point occurs. Okay, it's used to display how often a single data point occurs. Right? If you look here, right, these are all representing single data points. 0, 1, 2, 3, 4. These are all single data points here. Okay? Things to remember. Okay? Each dot counts as one data point. Histogram. Okay, histogram. Okay? This is not a bar graph. Okay? A bar graph is actually more closely related to a dot plot. Okay? Histograms, you're like, Mr. Witt, I see bars and it's a graph. It's a bar graph. It's not a bar graph. Bar graphs are more like dot plots. Okay? Bar graphs are used to compare different things. Okay? So in this case, like, these are carrying different numbers of passengers. But here, and I guess they're all talking about passengers there too. So maybe even a bar graph wouldn't, maybe I wouldn't even say a dot plot was like a bar graph either. Never mind. A bar graph is used to compare different variables. But dot plots and histograms, we're comparing the same variable here, right? These are just passengers, right? For histogram, and this is, I don't know what the label is for these, but it's also just the same kind of idea there. So histogram is not the same thing as a bar graph. They are different things. Anyway, histogram, okay, it's also used to display how often a category or range of data occurs. Okay? So you see the major difference here. I'm going to zoom in so I can try and show this to you here. Okay? For a dot plot, you have individual numbers graphed. For a histogram, you'll have ranges of numbers graphed. Right? You can see this first bar is for 1 to 4. Or 1 to 5 maybe, and the second bar is for 6 to 10, the next bar is for 11 to 15, the next bar is for 16 to 20, the next bar is 21 to 25. So it's a range of data. Okay. Okay, things to remember. The graph does not describe individual data points. Okay? In a dot plot, right, you can look there and see, there's 2 dots above the 2. That means my data has 2 number 2s in it. Okay? You can see there's 1 dot above the 4. That means this data set has 1 4 in the data set. But if you look at your histogram, all right, you can see the height of the bar here, let's say like this one right here is about like 30, okay? There's 30, but you don't know the exact numbers. There's 30 that are numbers that fit between 6 and 10, but you don't know what the actual numbers are. They could be all 6s, they could be all 10s, they could be a mixture of 6, 8, 7, 9, and 10. You just don't know, okay? So a histogram, by putting the data points together, okay, we lose, what the actual data points are. Whereas here we can see what the actual data points are. All right, and finally, Hannah's favorite, the box and whisker plot. All right. Box and whisker plot, why is it used? Okay. It displays the center, and what did you say there, John?
I was going to say the center of the
Yep, the center and also the spread of the data. Okay, it displays the center and the spread of the data, right? The center, that's that middle part of the box, that's our median right there, right? But also how wide the box plot is shows how spread out our data is, right? The more wide, the more spread out. The less wide, the less spread out. Okay. Things to remember of the box and whisker plot. Again, it does not describe individual points. Okay. Does not describe individual points. Okay. It's the only plot that gives all individual points. The dot plot gives all of our points, right? But the box whisker plot is just, it's only really 5 numbers. Okay? It only shows 5 numbers. The lower extreme, the upper extreme, the lower quartile Q1, the upper quartile Q3, and then the median. That's it. Okay? So, question on any of that? All right. Let's do a dot plot here then. Boom! Does anyone still need this side? Sorry, did I go too fast? I don't want people to miss out there. Okay, so turn your papers over there. Anyone still writing? No? Okay. So let's look at our dot plot here then. Okay? We're going to graph these data points. Okay? You'll see we've got a number line here. All right? Now we've got to make our number line, right, for this data. So what are we going to look for in our data here? What do we want to find to help us make our number line and label it correctly? We want to look for the what here? The lowest number and the highest number. Exactly right, because we want to make sure we get all of our numbers accounted for there. Okay, so what is the lowest number in our data here? 12. Yeah, so go to 12, and we have to count up to what? 19. Okay, so I think we should, let's count here. 12, 13, 14, 15, 16, 17, 18, 19. Yeah, so I can do that. So let's just count by ones here. Okay. Now, a dot plot. And it's called a dot plot because you can use dots. Some people use X's though too. Like Alec, I think you were using X's, weren't you, and stuff like that for your graph. So you can use X's, you can use dots, whatever. It's your choice there what kind of symbol you want to use. Okay? My recommendation, okay, you can do it one of two ways. You can start with 12 and then just look for 12s in your data and cross them out as you go. Or you can start with your data and just go, okay, there's a 12, so I'll put a dot there, cross it out. The next one is a 15, cross it out. 14. So it's really your choice how you want to go about doing it, okay? So let's just go ahead and fill in our dot plot here. I hope I don't run out of space. I'm a little concerned. I might be drawing my X's too big. We shall see. Yes. Okay. What is the mode for this set of data? 15. You guys see how quick you were able to answer that question? Imagine without the graph, if you were looking at just those raw numbers there. It'd be a lot harder to answer what's the mode here, right? Because you have to like see, all right, well, I see a 15 and a 15, and like, oh wait, but I see like another 16 and a 16, but there's some more 15s. Much harder. So with a graph, you can see what the benefit of that is, right? You can see what the data is, okay? What the mode is, at least very easily, okay? What does it look like is the center of our data? What value, what number is like roughly the center of our data here? Probably 15 as well, right? If you look here, we kind of have some points to the left of 15, we have points to the right, so about 15 or 16 maybe right around in here, right? So again, the benefit of a graph, you can like quickly and see where that center of your data is, okay? Does it look like we have any outliers in this situation? Probably not, right? Those are all pretty tightly clustered, I'd say. Nothing too crazy, right? If we had like a 30 or a 50 or a negative, 50 over here or something, then we would definitely say outlier. All right, let's continue on here. Box and whisker plot, okay? Talking about the details about a box and whisker plot. All right, this middle bar, what is that again? The median, also known as Q2 there if you want to think of it. But then yes, the left side of the box is Q1, also known as the lower quartile. Okay. And then this right side of the box, Q3, also known as the upper quartile. Yes. And so this far right here, the farthest right point, you'll see we don't graph anymore after it because this farthest right point is supposed to be the highest point. We call that the upper extreme. Extreme not because it's cool and does skateboarding and cliff jumping or something like that. Extreme because it is the farthest. Okay, it's the farthest out. And then there's like the lower extreme over here. So this whisker right here, what percent of our data is represented in this whisker? 25%.
Each order is 25.
Yep, and then so the left part of the box here, 25%. The right part of the box, 25%. The right whisker, 25%. Now, is it weird to anybody that the 25% here is a different size than the 25% here, or that like this part of the box is 25%, but then this bigger part of the box is all 25%? Is that weird to any of you? Okay, it's weird that we're calling this 25%, but this 25% as well.
Just because they're spread out.
So exactly right. You got to be careful here. So you got to think in terms of the data points, right? What this is showing is that this 25% is more concentrated. The numbers that fit in there, remember this is just the number of data points that fit in here, right? So 25%, 1/4 of the data points are in here. This 1/4 of the data points are a little more spread out. They're not as close together. That's why it looks wider, but it's really describing not 25% of the shape, it's 25% of the numbers, of the data points. And these data points just happen to be more spread out than these data points are. That's all. Okay? They're not as close together. Okay? And again, that can mean something too, potentially, when we're talking about data. Okay? So, let's see here. All right, yeah. So what we'll do then is, you guys, let's do that real quick here. So do you guys remember, how do we find all of these numbers? Lower quartile, median, upper quartile, upper extreme. How do we find all these numbers? What can we use to find all those numbers? We can use, stat, 1-var stats. Stat calc, 1-var stats there, okay? So what I would like to do here then, we're going to go through these as well. I'm going to skip these first couple here. Okay, I want to jump right to creating the box and whisker plot for the data. Okay, so I'm going to skip these first couple questions. We're going to go jump right to the box and whisker plot. So, how do I enter this data into my calculator? Where do I put it? Stat edit, right? Stat edit. Okay, so I'm going to clear out my old data. Make sure you press the clear button so arrow up, hit L1, hit the clear button and enter, it clears it out. Okay, then I'll type in those numbers. So 67. Okay. Any of those numbers look weird to you? 120 looks weird. Yeah. Seems kind of out of place, right?
Yeah.
So we'll see. Any other numbers look weird there? 80 maybe?
34.
34 might be too low. Yeah, that's true, Eric. That's right. So we will look for not only numbers that are too high, but also too low, right, for our outliers here. So, all right, I got all my data typed in. Now, do I press again? Sorry. Stat. Calc. 1 variable or 1-var stats. Oh, I have L2 still typed in there, so I'll change it back to L1. Calculate. Okay. Now for the box and whisker plot, do I need X bar here? No, I don't need the mean for box and whisker plots. Do I need any of these numbers up here at all actually? No, we gotta scroll down. These are all the important numbers, right? Min, Q1, median, Q3, and max. All right, so I'm going to write these. Hey, look, this is sometimes called the 5-number summary because 5 numbers that summarize our data. So the min is 34, the Q1 is 48, the median is 65, and Q3 is 80, max is 120. Okay? Now, here's my number line. Should I do the same thing I did for my other number line? Start at 34 and count by ones here? Probably not a good idea, right? Because I got to get all the way up to 120. So what would maybe be a good place to start my number line at? 20, okay. And then, again, I don't want to count by ones. What would maybe be a good number to count by? Tens. Let's try tens. We could do 20s as well if you wanted to. Let's try tens. Let's see if tens fit. So 20, 30, 40, 50, 60, 70, 80. Whoops, got ahead of myself. 90, 100, 110, 120. Whew, just made it. The scale you choose okay, the scale you choose is also going to affect how your graph looks. Okay, so I think Chloe, was it you that suggested 10, counting by 10s?
Yes.
Okay, Alex, was it you that suggested counting by 20s? Okay, so Chloe counted by 10s. Her graph, if we compared it to Alex's, Chloe's graph will look more spread out. Okay, because we're counting by 10, so the graph's more spread out. Whereas Alex's counting by 20s, it's going to be a little more closer in. Okay, if we compare the two because of the scale. Okay, so that's another important consideration whenever you go to like graph something. If you go on to continue in statistics and stuff, that'll be important. Okay, to understand. All right, so minimum 34, and now we're just going to kind of eyeball things here. So there's 35 halfway, so go a little bit less than that, and I'll put a point right there. It might not be a bad idea to put the actual number above that, just so you know. Okay, so you don't have to like keep guessing what you graphed there. I'm just going to put the number above it. Same thing here with Q1 at 48. Now for the Q1, what kind of thing do I draw? A line, right? Because we're drawing the part of the box now. Q1 is part of the box. And that's 48. Okay? Median is 65, so that's exactly half between 60 and 70. And again, what should I draw for the median? A line as well. Yep, another line. Very good. 65 there. How about the median? Q3, sorry. What do I draw for Q3? Another line again. The end of the box. And then max at 120, what do we draw there? A dot, because that's the end of the whisker. So we'll connect the Q1 median and Q3s to make their box. And then we'll make our little whiskers. It's curious like a cat. That's why they call it whiskers. Oops, I forgot to put my extreme there. Okay. So, number 6, what's the range of the data? What would we do here to find the range? 120 minus 34, very good. Okay, which ends up being 86. Okay, that describes the spread of the data, how spread out it is, 86. Right? A lower range, less spread out. Bigger range, more spread out. Okay, let's answer this one more question here, and then we'll call. Actually, no, I want to answer the rest of these questions. We'll do that real quick. All right. Well, we'll skip this Q1. Number 7. 50% of the data is below what number? 65. Right. Okay. Because 65, that's the median. Half of the data is below it. Half the data is above it. Right. This below 65 is one part of the box and a whisker. Above 65 is the other part of the box and a whisker. Okay. What is the interquartile range? How do we find interquartile range? Q3 minus Q1, so 80 minus 48. Did she finish? Yes. Okay, cool. Yep. Thank you. Okay, so yes, 32. Okay. Why do we bother with the interquartile range? Because that's the middle 50% of our data, and that tells us how spread out the middle 50% of our data is. Remember again, for our data, we're oftentimes interested in the center of our data and how the data is spread out. So interquartile kind of talks about both things. It talks about how much the center of our data is spread out. Okay, that center part, the middle 50%. Okay. Oh shoot! I just said that. What does the interquartile range indicate? The spread of the middle 50% of the data. Okay. Now I'm going to hold off on the skew stuff until later, okay? Because I feel like that's more than we want to talk about. All right. For homework, what I would like you to do is just to finish 1 through 4, right there. Those 4 questions, okay? That'll be your homework question. The mean, median, outliers, and do outliers have a great effect on the median or mean? Okay, so those 4 questions there for homework. And yes, of course, Eric. Yes, sir.
Do test correction. No.
We can talk about that. Probably going to set tomorrow. How about that? Okay. Okay, Erica.
Thank you.
Well, I know the video will be posted online, so you can check it out and see what you missed. Yeah.
So, will they like make me do the thing part before?
No, it'll definitely be after.